Okay, so now that we have understood what casting means and how casting can be used to validate certain points, let's get into more details and add some more actions and more items from Unreal Engine to our scene itself. So I will remove, basically I'll remove all of it, the strings here, and I will still use the casting as a element, one of the node, which still we will be using it for our purpose for emitter. So let's say in our level we would like to display some kind of particles. Now particles in Unreal Engine are another set of function which allows us to create different kind of effects, either in the form of fire, smoke, rain, snow. There is a lot of usage of fire, for particle system in Unreal Engine, and it allows us to create basically special effects in our games itself. So, in our case, let's say that we want to use one of the particle system in our level itself, and we would like, let's say, we would like that in this, when the ball rolls around and it passes through, let's say, the box collision, we would like the particle system to actually show up in this area. So let's try to do that one, and I'll take you forward with that one. I will go back to our blueprint and I'll just go back, and we don't need the sphere now, since we have already understood how it works actually. That will also of course tell us that since we have deleted, it is going to give us an error that this is no more valid, this particular node, because we don't have a sphere anymore. So let's just remove this also, and what we are left with in our system, in our blueprint, actually is a cone. We don't need the cone as well. For the sake of just simplicity, I'll just have the cube itself, and we still have the box, our collision box. Let's go to the event graph, and under the event graph, what we will like to do now, let's just delete the print string as well. What we would like to do is to do the casting again with our physics ball BP. So when the ball follows through this one from the box itself, the collision box, or collides or overlaps, we would like particle system to show up in this area. So let's go do that one. So first things first, let's do cast to, what was it, our physics ball BP. Okay, that's the first thing. Now the second thing was, if an actor actually is going to hit our collision box, so that node which we need to take actually is from this particular point to our object. So basically it will allow us, okay, that what exactly hit in this case, or what collided. So that is our, in our case, is a physics ball BP in this case. Now there is a new node which I would like to introduce. It's about emitting particles, and I will show you exactly how it has to be done. And we want to actually execute those by dragging it and typing spawn emitter. Yes, spawn emitter at location. So let's just click on this one. So you see this node has a lot of properties to it. So there are a lot of properties for the emitter at location, and what this essentially does actually is that it will allow us to select a template of an emitter which is of a particle system. If you can see, if you hover up over it, it will show you emitter template particle system. So if you click on the drop down, you will see that we have a lot of particle system which came along with what you call our starter content. So we would like to actually use one of them. Let's say we will try the what you call, yeah, I think p underscore fire. Okay. Now, once we have the particle system, of course, we need now the next thing is to tell Unreal Engine that where exactly this particle system is supposed to be spawned. So in that case, what we need actually is that we have another node, and that node actually is going to tell us that wherever our what you call the collision box is, it is supposed to actually emit in that particular location itself. So if you see here, you will see that we have another type of pin, and this is basically it's yellow pin itself, and this is for vector type of the node itself. So we had actually before float, we understood also string, and now we have another type called location, which is of vector type. And if we drag it from here, I can get another node called get actor location. Great. So essentially what it is doing now, that it is checking on our loop, our level, and is saying that in this world, this whole world, this particular box actually, which is our blueprint, which is of my new actor, is in some location in this particular level itself. So what it does, that it takes basically the location of that particular what you call of the actor itself, and it plugs into the emitter and saying that this is exactly where I want the fire to actually the particle system to show up. So let's compile and let's test it and see if it actually works. Okay, now if we move here and we try to move the mouse close to it, and there you go. Now you see here that we have a fire running out in this particular location where the collision box was, as soon as our ball actually overlap with the collision box. So that's a success. Now let's move on and let's get more deep understanding of the overall node itself here. Now if you see and try to drag what you call the return value of the get actor location like this, and if you type break vector, okay, break vector, what it will do actually is it is going to break the vector value, which is the return value out of it, into its three axes. So vector value has three axes, actually it's x, y, and z. And once that we have the x, y, and z, what we can do is we can further manipulate the values of x, y, z into different directions. Now x, y, z values are of float type. If you see here, you have a green color for it actually, and if you can see that from the vector you can actually add another value to the float to actually tell the emitter node itself if you want to emit these or spawn these particular particles at a different location. So how can we do that actually? Let's do, and I'll try to make you understand how it works. Is that you go to the vector, and let's say on z-axis, which is actually on going up in this case, so it will be if you scroll, move down, the one which is showing up actually is on z-axis. Let's say we want to show our fire particles not at this surface actually, but actually somewhere at the top. So to do that, what we need to add some kind of value to our float. For we want to add something to on the z side axis. So what we can do is type add, and under add, under the operators, select function add. You will see other adds also, but for our case, add operator means that add is a plus sign actually, which is now in the form of addition. So once you have it, you will see here now that you have particular addition which you can do in the z-axis, and you can increase the values here, and that will actually add up to whatever value of z of this cat actor location was. It will add those units to it. So let's say we have like 200, and 200, after having 200, it will add the 200 to it. And then just like that we can have a break vector, we can create a vector as well. So let's do that one. I think it is create vector, sorry, add vector. So what we can do is same like how we did the break vector from the vector, we can create another vector from a float point. So how we can do that? If you can drag one of the pins from here and say make vector, there you go, under the math node, you will have another node. Let me just have a little bit space here, so we can have a clear understanding of what's going on. So now you have a make vector which also have the float values as input. So what basically this node does is takes in input of float values, convert them into a vector as a return value, and then you can use that return value into your location, and it will actually take the location of that. And in addition to that, whatever we have added from z component, z axis from this vector, in terms of let's say 200 units, it will add to z, and once you connect back to the z axis of the make vector, so it's taking 3 inputs, it is also requiring 3 inputs, so y also the same. So we take it from the original value of your actor location, and now what it does actually is that it's creating a new vector that will have on the x-axis the same position where our actor location is. It was taking the y position of our actor location is, and it is taking the z value as well, but in addition to whatever was there in z axis for our original actor location, we have added 200 to it. So ideally now what it should do is to add up all these float values, create a new vector out of it, and then we can plug in this particular pin into the location. There you go. So now what we have done basically is that instead of just showing the particle system, the fire particles basically on that location, we are going to move it up a little bit and show on a different location once our ball actually is going to overlap it. So let's play and see what happens. So here we go, and let's try and see what happens. And there you go. So you see now that we have successfully created and shown the particles not just on that location where the collision box is, but actually somewhere at the top of it. Now, why would you actually require these kind of functionalities? Just think of your level that you have certain elements which might be somewhere here on this particular boxes, and you are supposed to find out something here or act on that one by this collision box, which would actually trigger it on this particular location. So instead of showing it here, you want to show it there, and we will come to those areas as well, that as soon as we're gonna get into more details of game development and have different locations, be it not just the emission of the particles, but maybe we could do certain animations. Maybe we can do certain other aspect of Unreal Engine which allows us to let's say for opening a door itself. I mean, there are multiple possibilities which you can. It all depends on how your gameplay is going to be. So having said that, let's move further and see how our things, what we can do further with this particular node in this particular fashion. So let's see what exactly we are getting on when we actually playing. So when we move our ball through the box itself, you see that we have created a fire. However, let's do it again and again and again. So every time you are passing through the box and it's overlapping with the box, the ball, you see the fire is increasing. So what exactly is happening? So what exactly is happening here is that every time we pass through the collision, it is spawning the particles at the location every time. So it is increasing the fire. That's how you see that it's increasing the fire. And this actually is not very efficient. This is, I mean, you don't want in a game that where you want a particle system overlapping another one and multiple times. This will actually cause a lot of resource usage for no reason, something which you don't need actually. So I would like to actually show you that how you can once once the ball has passed through from the collision box, how you can actually destroy this particular particle system from that location in order not to show it again. So let's do this one. If you see from the spawn emitter at location, that we have a return value which is showing particle system component object. Now what we can do, we can store this value into a variable. So let's go back into variables, and if we click on variable type, so here it is same, because last time we selected boolean, that's why it is still showing boolean, but you can change it. And in this case, if you go on the right side and in the variable type, based on what value you have here, a particle system component object, so let's say we type the same particle system component, okay, component object. So we can select this one and we can type fire particle, okay, and we have our variable created here. I'll just compile so that we'll have this also available. So if we drag this particular variable here and we say set particle, so what it will do, if we connect the both nodes and we connect the return value to the fire particle variable, which is this one, it will actually set the value of the reference of this particle system into this variable. Now you can easily do this by creating these particles, but I would like to also show you another method of doing it. So let me just delete this one and delete this as well, and let's take from the return value, and in this case if you see here, you can say that whatever is actually coming out of this return value, promote to a variable. So you see directly it has created a variable which is of course of the same type as a particle system. It has given a name, new var 0, and it is also assigned that this is the type of the variable itself. What we need to do is just to change the name of the particle, the variable itself. So fire particle, fire particle. Now I want to introduce now, same as like what we have an on component begin overlap, we can also have on overlap end. I think it's on component. Let's try this one, and overlap. Yes. If you see here now, just scroll up actually, you see here that now you have an add event which is of add on component and overlap. Make sure that you don't select anything else. It is showing here for the box itself, and this is the node which you need to use. So we can select here and we can have a node which is going to show that whenever there is an overlap end with the box collision, it should do something. To make sure that actually it was the ball which was ending the overlap, we need to again do the casting. Cast to BP physics ball BP. Okay, great. And we also take the other actor object into the object itself to make sure that we have an actor which is actually colliding or ending the overlap. Now in this case, if we want to do exactly that, what should happen if it was indeed the ball which is ending overlap, we want our particle system to actually get destroyed. So let's say get particle fire particle. This is the variable value which is actually holding the value of our fire particle for that location. And if you drag a pen out of it and you type destroy, this is the node which you need to use, destroy component. Okay, and let's do one thing. So on successful casting of physical ball PP on ending the overlap, we want to execute this particular node, and practically what is happening now, what should happen now actually, is that on that location where we had the fire showing up, spawning up, in this case particle system, at the same location on ending the overlap by the ball, that should destroy and hide itself. So let's go and play. Okay, so let's move and slowly try to move to the box, and you see here that we have created the fire. Now if we move out, and there you go, we have no more fire. Go in, go out, go in and go out. So now you are not doing actually spawning the particle multiple times in the same location, but only when the collision is happening, and that's happening, and once it's out, it's no more there. So if you go back to our blueprint, what you have understood out of all this, that you have created an interactivity on when the ball is actually interacting with the collision box, and it is doing something in terms of particle system spawning the particle on a certain location. We are storing that particle system value in a variable, and this is how you come to know also that how important variables are in our Unreal Engine, so that once we have that value set, actually we can use that value for certain purpose to do it. So you will be using a lot of variables for different purposes throughout the whole course, and of course when you are actually developing a game, you will see that you will be requiring different types of variables to do different kind of functionalities at different level. So having said that, we'll move forward with the next topic itself.